Hey there, biochemistry students. Today what we're going to take a look at is what happens to an amino acid as we change the pH. Now, amino acids can be drawn in a number of different ways. The thing that makes them common is that we're going to have a nitrogen here with two hydrogens, a carboxylic acid, and then some R group. Now, we can rearrange these in any way we want, and it doesn't really change what the amino acid is. Now, in your guided inquiry workbook, the way that they arrange it is a little bit different than this, and they put the carboxylic acid up on the top. So just to keep it consistent, I'm going to do that. I'm going to change this here. Put my carboxylic acid up here at the top, like this, and then I'm going to put my methyl group down on the bottom, and then my hydrogen over here. Now, this doesn't change anything about the amino acid. Okay, now, in a neutral pH, that is to say at like a pH of 7, I'm just going to say neutral pH. At a neutral pH, this hydrogen from the carboxylic acid leaves the carboxylic acid and is attracted over to the lone pairs here on the nitrogen. And so what this ends up looking like is this. We're going to take this hydrogen off of here. That makes that negative here. And then we're going to add another hydrogen here. So I'm just going to go like this. I'm going to make this NH3. Okay, so that's at a neutral pH. We just take a hydrogen from here and move it over there. Then the question is, what happens if we change the pH, if we make the pH higher or lower? Now, these types of reactions can go both ways, and that is to say that they reach some sort of an equilibrium. And so we make double-sided arrows like this to show that they could go in both directions. And we're going to take a look first at what happens at a high pH, so a very basic solution. High pH, basic. It's a basic solution, and one way to think about this is maybe that we have lots of hydroxide ions. That would help us then to see that we have a very basic solution or a high pH. So what happens to our structure here? Well, our structure stays mostly the same. Let's see, hydrogen here, C double bond, and H like this, and then CH3. Okay, now in this example here, where we have a very basic solution, we have lots of OHs. Those OHs are attracted to hydrogen ions to form water, to form H2O. So they're going to strip this molecule of hydrogen ions. And so this here, we have one that's loosely attached to this nitrogen lone pair. And so we're going to lose a hydrogen from here. And that is going to then go and form water. So our new structure here is going to look like this, where we just have one less nitrogen, or excuse me, one less hydrogen. And that makes this whole thing here a little bit electronegative. See, we have that one negative charge here that's not balanced off by the hydrogen that's over here, the excess hydrogen. So that makes this whole thing just a little bit negative and means it would be attracted to something positive, like say a potassium or a calcium ion. Now if we go in the opposite direction here and we make something that has a low pH. So a low pH, a low pH, that makes it acidic. And if it's acidic, we can think of this as having lots of hydrogen ions. So we have excess hydrogen ions here. Okay, so what's going to happen to our structure? Well, we have the same basic structure here. Like this. Let's see, we're going to do carbon, hydrogen, C bond O, and then CH3, and then NH2, like this. Okay, and what's going to, oh, wait a minute, H2 and H3. Okay, back here, okay, and like this, we've got our lone pairs here, 3, okay, and this should be a positive here. Positive there, okay. So now we have excess hydrogen ions. Those excess hydrogen ions are going to be attracted to this. This is electropositive, this is electronegative, and so we're going to end up adding that hydrogen ion up here, like this. And so that's going to make this overall net charge on this here electropositive, okay, because we have a positive here, and there's nothing else here that's negative. That would cancel that out, so this whole thing becomes electropositive, and that means it would be attracted to something that has maybe a negative charge. Okay, and then one last term on here is this amino acid, how it adds and loses hydrogen ions depending on the pH. When it's right here in this neutral solution like this, when it's neutral like this, where it's neither positive or negative, it's neither positive or negative. It's neutral like this. We have a fancy term for this. It's called a Zwitter ion. A Zwitter ion. Neither positive or negative.